let's talk about one of the most frustrating things that can happen during a competitive exam. I mean, it's this silent mark killer that gets you even when you've done everything right, even when your physics is absolutely perfect. So picture this. You've been wrestling with a really tough problem, and then you get that amazing feeling, that little spark of triumph when you get a nice, clean answer. And then you find out later you got a big fat 0 for it. Ugh, what a nightmare, right? It's just the worst feeling.
And you know what makes it sting even more? It wasn't because your concepts were shaky or your method was wrong. Nope. It was because the number you circled was simply not the number the examiner was looking for. This is exactly what I want to warn you about today. It's something I call the second quantity trap, and honestly, learning how to spot this thing is an absolute game changer. So what is this trap? You know, the one that so many really smart students stumble right into? Okay, let's break it down. All right, here's the idea. It's when a question asks you to find, let's say, quantity A. But to get to A, you first have to calculate this other value, this kind of stepping stone value, quantity B. The trap is when you get to that stepping stone and you think you've reached your destination. So here's how your brain gets tricked. You do all the hard work, right? You find quantity B. The clock is ticking, you're feeling that pressure, and in that rush, you mark B as the answer and you move on, completely forgetting that last vital step. One tiny slip and a full mark just vanishes. So this is it. This is the golden rule I need you to burn into your brain. In these exams, the number you calculate is not always the number you're supposed to report. You have to stop and ask yourself, what exactly is this question asking me for?
Okay, now for the fun part. Let's go on a little safari and see this trap out in the wild. I'm going to run through 5 really common examples from all over physics just to show you how sneaky and widespread this thing is.
First up, electrostatics. You've got a classic problem, maybe with concentric shells, and it asks how much charge flows to the ground. The trap is to define your variable x as the final charge on that shell. The smart way, the correct way, define x as the very thing the question is asking for, the charge that flows.
And that really is the key lesson here, isn't it? That final charge on the shell, it's just a tool you use in your calculation. It's not the final answer itself.
Let's jump over to mechanics, and you'll see the pattern continues. The question asks for the kinetic energy that is lost in a collision. The trap? You calculate the final kinetic energy and you stop. The right way, of course, is to find the difference between where you started and where you ended up. It sounds so obvious when we lay it out like this, but it is such a critical distinction. Are they asking you for the final state or the change that happened to get there? They wanted the loss, not what was left over. Next up, current electricity. The question asks for the charge that passes through the battery when you're charging a capacitor. The mistake everyone makes is calculating the charge that's stored on the capacitor, and very often those are two totally different numbers. And this points to a really deep concept. The total amount of charge that moves around in a circuit isn't always the same as the amount that gets stored in any one part. And it doesn't stop there. Here we are in thermodynamics with a heat engine. The question asks for the work done. The trap is to calculate the heat absorbed from the hot part and just mark that. But the correct answer requires you to use that value to find the work. You see, the lesson is so fundamental. Input is not the same as output. The heat you put in is just the starting point. It's not the final result, which is the work the engine actually did. Okay, our last example, this one from the photoelectric effect. They ask for the maximum kinetic energy of the electrons. The trap is to find the stopping potential in volts and just write down that number. But wait a minute, voltage isn't energy. You have to take that intermediate value, the voltage, and use it to find the final physical answer, the kinetic energy. This is maybe the most perfect example of the second quantity trap in action. Okay, so we've seen this enemy in 5 different disguises. Now for the most important part of this whole thing. How do you build a defense against it? What's the antidote to this trap? First, we have to really appreciate just how dangerous this is. I mean, look at this. Your physics concepts are perfect, your equations are right on the money, your math is flawless, and after all of that, your answer is still wrong. It feels totally unfair, but hey, that's the reality of these exams. So here's some practical advice. You need to train your brain to see certain keywords as giant red flags. Whenever you see a question use phrases like how much flows, how much is lost, or how much is transferred, A little alarm bell should start ringing in your head.
And this, right here, is the single most powerful habit you can build to protect yourself. When you see those trigger words, define your variable x not as the final amount of something, but as the change itself. Let x literally be the amount that was lost or the amount that flowed. That way, you're solving directly for what they're asking.
So why does this matter so much? Because we are talking about a potential swing of 10, maybe even 15 marks on a single paper. I mean, think about it. That's the kind of margin that can be the difference between getting selected or not, between your dream college and your second choice.
All right, let's wrap this up. I want to leave you with one central idea that you absolutely need to take away from this. This is the final truth of it all. The top rankers, they don't just solve problems. They interpret them with incredible precision. They get that marks are lost not because you don't know the material, but because you accidentally answered a different question than the one on the page. So from this moment on, make this your mission. Learn to identify that second quantity. See the trap before you even get close to falling in. Solve with the mind of a physicist, for sure, but answer with the discipline and the focus of a topper.